Hello, welcome to Mr. Denny's Applied Math class. I'm going to now talk about how to multiply fractions and mixed numbers. All right, I'm going to present my screen to you here. All right. So, we've talked about adding and subtracting fractions. We've talked about how a fraction is like what the parts represent. The top number represents how many parts we need. Sorry, the bottom number represents how many parts we need to make a whole. The top number represents how many parts we have or don't have. All right, so when we're going to multiplication, remember that multiplication is really repeated addition. It's actually just a quicker way to do addition. And one thing to remember too is in word problems, we often use the term or the word of to describe multiplication. Now, we're going to start with addition just to kind of see that connection between addition and multiplication. With one problem here, how would I model the following situation? I need to cut 4 pieces of wood that are 3.5 inches long. How much wood would I need? How much wood could a woodchuck chuck if a woodchuck could chuck wood? Psych! So, if we have 4 pieces of wood that are 3.5 inches long, we can write this, remember, we're going to start with addition here. We can write that as an addition problem by going like the following. All right, 3.5 plus, do that 4 times. And recall from when we're doing adding and subtracting fractions, the most common method in order to work with mixed numbers when we're adding and subtracting of fractions / mixed numbers is to change the mixed number into an improper fraction. So I'm going to go ahead and do that. And 1/2. That's the same thing as an improper fraction. Well, 2 tells us, hey, we need 2 parts to make a whole. Or in other words, every whole that we have has 2 parts. So if we have 3 wholes, and they each have 2 parts, or they're made up of 2 parts each, then we can go 2 times 3. That gives us 6 parts altogether, plus the one that's hanging out that never quite had a friend, never was made into a whole. Okay? So 2 times 3 is 6, plus 1 is 7 parts total in this mixed number. We can change that to an improper fraction, or as some of you mathematicians like to say, a fraction greater than 1. And then we can rewrite this problem here as 7 halves plus itself 4 times, or 3 times, I guess. Altogether 4. Now, adding, subtracting fractions. Remember the rule, add only the numerators, or the top numbers, okay, when you have a common denominator. So we got the common denominator, check. Now we just got to add the tops. 7 plus 7 plus 7 plus 7, it gives us 28. And now, typically, you reduce it back to, or simplify it back to a mixed number. And the easiest way to do that is on this one, 28 divided by 2 give us 14. And on these type of problems, don't forget to put your unit. I'm going to delete this here so we have some room. 14 inches. All right, now, how do I model this as a multiplication problem? Well, this is okay. All right, and this is kind of the way math would probably tell you how to do it. However, in the field, this is kind of cumbersome. In order to, when you're out on the job, working with improper fractions is just a little bit harder to hold in your head, perhaps. I would rather solve this addition problem in a separate, little bit different way, and I'm going to show you how to do that right now. So using this property here, or this fact, okay, that 3.5 is the same thing as 3 plus 1/2. All right, that's how we're gonna think about this problem. We don't normally write the plus, but it's there. Okay. This might help us think of this where we don't have to work with improper fractions, and we might be able to do more mental math here. I'm going to write it down for you, but really it's going to be more mental math. So 3 plus 1/2, and I'm going to do that 4 times. And again, addition is a pretty neat thing. It has this property that you can move the order of what you're adding as long as all you're doing is ordering, as long as all you're doing is adding. And you can make it a little more organized by doing the following here, 3 plus 3 plus 3. And then we can add the fractions. I'm just kind of rearranging the order, how I'm adding. And that's pretty nice because it's really easy to see now what I need to do. Well, plus 3 plus 3 plus 3 is 12. And I've got half plus a half. I'd probably just do that because that's an easy one. And then I got another half plus a half, and that's another one. And I end up with 14. Same answer as before. So that's not too difficult to look at. And in fact, all this can be done in my head relatively easy. This is a little bit tougher to do in my head. So if I'm on the job, I'd probably just in my head think, well, 3 plus 3 plus 3 plus 3, add the wholes first, and add the parts, half plus half plus half plus half, and then I put them together. All right, now that's all addition. Mr. Denny, this lesson's supposed to be about multiplication. Well, again, multiplication is simply repeated addition. All right. So how I would actually look at this problem right here is I would see that I need 3.5. Actually, I'd probably look at it this way. 4 times, and I need 4 of these 3.5 pieces of wood, so I do 4 times 3.5. Now, I could go to an improper fraction, and I'll show you that at the very end, just in case you're real comfortable with those. But really what I would look at here is I would say, hey, I got 4 3s. I look at the wholes. So I'd say I've got something like this here. I need 4 inches. And I also need to add that then to my 4 halves. I do this in my head, but I'm writing it out for you here. Now, does that make sense? Well, it really does, because look what's up here. We've got 4 3s. We could just change that to 4 times 3. And then we're going to add it to, hey, 4 halves here. Another way to think about that is kind of a distributive property here. We got 4 times 3 plus 4 times a half, right? Because remember, this is the same thing as 3 plus a half. And then in my head, I do, well, I need 4 3s, that's 12. And I need 4 halves, well, that's 2. And what I then, I need 14 inches. This is how I do it. I do this in my head, nice and quick. Now, again, if you're not comfortable with that, and you really want to stick with this method here, all right, that's okay. I can write that as 4 times 7 halves. Okay. Now you just have to remember a property, another property. Anytime you put a number over 1, whole number over 1, okay, it's not changing the value. It's just rewriting it as a fraction. And if I have a fraction times a fraction, the rule is you multiply the tops and you multiply the bottoms. At least I hope that's the rule. Let's go back and make sure. Well, looks like we end up with the same thing. So I'm pretty confident that's the rule. And now we just need to simplify that, 14 inches. So there we go. You just multiplied a mixed number. All right, here's a question for you. How would I model the following situation with a math problem? I have a patient who has a rash that is 3/4 of an inch wide in diameter. Got bit by a spider, maybe. All right, now I know if the rash quadruples in size, this is what the doctor told me. I need to call him. How big can the rash get before I need to call the doctor? All right, quadruples. Quadruple stands for times 4. 4 of them, okay? So if I take my 3/4 of an inch and I multiply that by 4, notice it doesn't matter which side the whole number is on. I could 4 times 3/4, 3/4 times 4 is the same thing. All right. How big can it get? Well, like last time, we got to put this over 1. And we talked about the rule for multiplication is you multiply the tops, multiply the bottoms. And you can simplify if you can. Again, this one's a pretty easy one to simplify. If you just take the top number divided by the bottom number, you end up with 3. Now let's say it wasn't quite so easy, just an example here. I'll delete this in a minute. What if you had like 11/4? No biggie. Just think about this. Remember, we got 4 parts to make a whole. We've got 11 of those parts. So these 11 parts, how many times can we group them into groups of 4? 11 minus 4 is 7. We got 1 whole. 7 minus 4 is 3. We got another whole. So 2 holes. And we had another 3 parts that we didn't use, 3/4. Alternatively, if you stuck this in your calculator, 11 over 4, 11 divided by 4, you get 2.75. And then you'd have to take the two holes, and you'd have to figure out, well, and 4 parts are in 2 holes. So that means I used 2 times 4, 8 of my parts. 11 minus 8 gives me 3/4 again. A couple different ways to look at that, and we'll probably go more into that later. But this one's nice. We don't have to do any of that. We can just go 12 divided by 4 equals 3. All right, when multiplying fractions, what parts do you multiply and how? So this is where we're going to write down what we just did. Is this different than adding or subtracting fractions? And if so, how? Well, let's see here. When multiplying, that's you multiply the tops. I'm going to put in parentheses. We call those things numerators. And the bottoms, call those things denominator, like the Terminator. And you put, let me add this here. You multiply the tops, numerators, and you put in the numerator position, okay? You put the answer. That's important. Multiply the tops, and then you put the answer in the top position. And the bottoms, and you put the answer in the denominator position. Then simplify if possible. Simply simplify. All right, is that different than adding subtractions? Well, yes, it is. When adding / subtracting, you only operate on the numerator, the top numbers. You know that mathematicians are doctors? They operate. You only operate on the numerators. And you leave the denominator same. I'm going to put in parentheses here. After it is common, right? We can't even add or do anything until you have a common denominator there. Multiplication then doesn't matter. You can multiply if you don't have a common denominator or not. All right, so make sure you understand these are the differences here. That's a little bit big. All right, one other aspect I want to teach you. Okay, I was at Subway and I was given a foot-long sandwich. You know, I was on a diet and I wanted a smaller size sandwich, so I was kind of upset because he's tempting me, right? Tempting me with eating this whole big foot-long, but I didn't want to get mad. I didn't want to yell. So instead, I just gave him a math problem to solve to help him understand what size sandwich he should have given me. All right, I said, hey, what is 1/3 of 12 inches? Because that's really what you should have given me. And then he kind of scratches his head. And he's like, hi, I know this. Mr. Denny taught me how to do this. So then he goes 1/3. Oh, not 1/2. Times 12. And he said, well, I can just put this over 1 here. And then I can multiply the tops. I can put that on top. And I can multiply the bottoms. And then I can just go, I'll simplify that. This one, 12 divided by 3. And that should have given you a 4-inch size sandwich, sir. All right, so that's pretty good. Now, I want you to think about this, though. Like the problem above, you might end up with a smaller number than you started. Okay, that's kind of weird, right? When we multiply, we usually think we end up with bigger numbers. But be careful, when you multiply with fractions, as long as the top number is smaller than the bottom number, you're going to end up with actually a smaller whole number than you started with. All right. Also, kind of important to realize is, what is 1/3 of? Remember I mentioned at the beginning, of in word problem stands for multiplication. That's why I multiplied here. But I want you to consider something here. Here's a couple of other problems. What is 1/3 of 6? What is 1/3, 1/4, 1/2 of 4? And can you write those both as multiplication and division problems? Starting to think a little bit about division now. Well, let's take the first one here. What is 1/3 of 6, or 6 teaspoons? So 1/3 times 6. I'm just going to put it over 1 right away. All right, that's going to give me 6 thirds. It's going to give me 2. Is there a way I could write this as a division problem? Well, there is, because look right here. remember fractions can be written as division problems. Really what ends up happening when I multiply by a unit fraction is what we call them here, where 1 is on top. So I end up taking the top number and I just end up dividing it by the bottom number. So in other words, rewrite this fraction 1/3 times 6. I could rewrite it as 6 divided by. Does that hold true for the one that we did up here? Well, 1/3 of 12. Yeah, look, it's also the same thing as 12 divided by 3. So there's kind of a neat relationship here. You can think of it in either way. When you have a unit fraction where the fraction, the numerator is 1, times by a whole number, really all essentially that you're being asked to do is take that whole number and divide it by the denominator of the fraction. So that's something that can kind of help us get into division a little bit, and a good relationship to remember, because it's kind of be confusing sometimes. You can kind of mix those up. And that's all that I have for multiplying fractions and guided numbers for you. Thank you for listening.